to LINQ or not to LINQ? That is the question. What's up, YouTube? In this video, we're going to be looking at LINQ and we're going to be looking at performance. Now, I don't want this video to come off as never use LINQ or don't use LINQ. I'm a big fan of LINQ from a technology point of view, but I'm not a big fan of LINQ from the point of view of usage, which is it makes it really simple to mess up. So this video is kind of in that direction. It was, I guess, the genesis of this video. The code you're seeing here is like real world scenario, if you will. I've of course had to modify it a bit. But the genesis of this entire benchmark that I'm going to show you today is the result of something that occurred in the real world, and then sort of the pursuit of trying to find a better, more optimal solution led us down a path where different members on my team came up with different alternatives. And so I put them all together to kind of benchmark and compare them all. So I want to show you that. The result of that here. My opinion of LINQ, it's a incredible feature. I think most languages actually don't have that feature yet. Maybe they don't think it's worth it. But as I said earlier, it makes it really, really too easy to mess up. And I don't like that about languages where it's so easy and you think it's coming for free or there's no cost to it in terms of performance or memory allocations. But then you find out later that that's a heavy cost there. So I use LINQ in sort of the simple scenarios. And even there, I will show you in this video, even in those simple scenarios, there are performance issues. But again, you know, what does a performance issue actually mean? If something is faster or slower, does it actually does it matter to you? Right? I think that's where you need to look at this video from, or anything based on performance, right? Or benchmarks. Nanoseconds, milliseconds here and there may not make a difference if that method is being called just once, let's say, you know, every second, or whatever the frequency that you have, right? But if it's a hot path where that method is being called so many times in a second, tens of thousands of times a second, then minor improvements in performance will give you huge gains. But if you call that method once in a while and it's millisecond to microsecond differences, I'm not sure that makes a difference, right? So I don't want you to chase performance for the sake of squeezing out performance, even when there's just the one method. But I do want you to understand the stuff I'm going to talk about here and the other benchmarking videos I've talked about. You need to understand what happens, why things get slower, so that as and when you have a need to make something as optimal as possible, you're aware, right? You understand the reason for why something might be slower or faster. So that's essentially the point of this video, right? So we're going to be looking at some code, and then we're going to look at an Excel spreadsheet where I've charted out the results to make it more visual. And then we'll discuss the reasons for why certain versions, methods, if you will, the benchmarking methods, the different ideas are more or less costly. So that gives you a better under the hood kind of sense of LINQ, how it works and what it does under the hood. All right. Okay. So let's look at the code here. So I'm going to basically explain the code here. There's a collection of customers here where the customer has a first name and a last name property. And I'm just going to put some names here, and then the last names will start with L. Okay. And the idea is that given a list of customers, and then given a list of 3 other customers, and it's not a list, of course, it's a hash set for a specific reason here. But the idea is these are also first names of customers that you've got from somewhere. The 3 completely different collections with only the first name is there. And the idea is you want to get the intersect, if you will, of these lists, right? Meaning any customer that's here and either here, here, or here in either of the lists needs to be your result. That's the basic premise or the idea for this thing. Of course, I've simplified this. I've pulled it out of context. It may not make sense to you. But as I said, this was the genesis of this whole thing was based off of some real need we had, where I was doing a code review and I found the baseline, if you will. I'll show you that. And then I kind of sent that out to the team saying, guys, okay, let's see who can tell me what the reason is for the slowdown or how to improve the performance of this thing, because we were having an issue. And so the team set out to implement various versions of it, and they sent their versions back, I benchmark them, and I'll show you the result. All right. But I hope you understand the basic premise is that you want to get a list of customers that are in here, or from this list of customers, rather. You want to get any customer that's in any one of these three lists. In other words, since there's a AAA, DDD, EEE, we want a AAA, but we don't have a DDD and EE, so we want a AAA from here. We want the BBB from there, and the CCC from here. Right? That's the output. Of course, it's case insensitive compare, so that's the other aspect of this whole test. Is some of things are focused on the two upper or two lower case insensitivity comparisons and the outcome of that. All right. I also have, in this case, an array of customers, but I also have an enumerable of the same set of customers. So one is seen as an enumerable of customer, and this is intentional. I'll explain why. And the other is an array of customers. So the set of customers or list of customers in each of them is the same. Right? They're exactly the same reference. This is the reference type. Just one is typed to be an enumerable of customer. The other is typed to be an array of customer. All right. Okay. Let's look at the baseline now. This was the original sort of code or style in which the code was submitted, saying customers.where, and then you do an OR for every one of the three different lists in this case, and this is a hash set, so you can use the contains, and you do a C, which is the current iteration, if you will, of the customer from that collection. Not first name, not to upper, but then you're doing it multiple times. So that, and the tool list is only to kind of materialize the list, if you will, so that, it's not a deferred execution in this case. So the tool list will force the execution of LINQ. Don't worry about it if you don't understand that. So the thing that triggered me to even want to start to optimize some of this stuff was the fact that the two upper here is multiple times. So you don't never ever need to do that, right? So the first order of business would be saying, okay, well, I don't need to do the two upper of the same name three times for the same iteration. Remember this, where this delegate would be called multiple times per element in the collection of customers here. So yes, you might want to do it once for each iteration, but you don't need to do it multiple times, right? So that was my initial thing. I said, okay, listen, we are having some issues here. That two upper multiple times needs to go. So let's try with that and see what happens, right? And so the question then became, but how do you do it? Like, where do you do the two upper and once in the iteration? If you understand LINQ, you'll say, okay, well, I'm not sure how I do that, right? So there are two alternatives in LINQ that you could do. One is to use the let keyword within the LINQ statement, right? So, but that would require you to write the query syntax, from, blah, in, blah, kind of thing, syntax. And the other is to use a lambda statement block, right? So we'll get to those two alternatives in the code that we see over here. All right, then somebody from the team said, well, let's just do this with the equality comparer. Instead of doing the two upper thing like we're doing over here, we'll define an equality comparer that is ordinal ignore case. If you want to see how that's, by the way, the source code and the Excel spreadsheet, all this will be available to you on my GitHub. In fact, I've shared this code before for a previous video as well, where we are doing other benchmarks. So this Excel spreadsheet in this project has got multiple benchmarks: string compare, string equality, a whole host of them. This is just one tab, if you will, in the Excel spreadsheet, so one of the benchmarks. With the source code available on my GitHub, I'll put a link in the show notes below. All right. So the string comparer here is defined as string comparer ordinal ignore case, which is sort of considered to be the best way to compare strings, their ordinal comparison and ignore case. And so it's defined, initialized as a single variable here up front. Then somebody on the team suggested, why not do a union or sort of combine? Okay, this is physically modifying the collection. This collection is being unioned with that and that. So these three collections are being combined into one, but it's a physical alteration. You can't go back. So we said, well, let's try it, like just get a sense of what it takes first and what it looks like. Then let's worry about whether we are modifying that collection and if that's acceptable or not, right? The benefit here is that in this case, you're comparing the same first name 3 times, right? There's 3 comparisons here. In this case, you're converting it 3 times per iteration. This is comparing 3 times per iteration. But here you are comparing it just once per iteration. The full iteration nonetheless, but you're not doing it multiple times. So this 2-upper is exactly once per iteration. This is the same as sort of an optimized version of it. So let's see what that looks like. In fact, let's look at the results. So you can, as I'm describing the implementation, you can look at the results as well. So the baseline, that is the baseline. And that turns out that it had average or mean time of 706 nanoseconds. Again, remember, these are all nanoseconds, so it's not like a whole lot or a huge deal. Keep your eye out also on the allocations that take place here. So this is using LINQ, of course. I don't mention it here, but the get using multiple 2-upper. If you're doing multiple 2-uppers, it takes about 706 nanoseconds, and it's allocating 680 bytes during that process. Okay, the allocation for some cases is the string allocations, the 2-upper, and other cases just LINQ has allocations. And that's one of the big differences between LINQ and, let's say, a for or a Foreach. Even a Foreach has allocations, a for loop does not. I mean, I'm not saying that you never have allocations depending on what you're doing inside the for, but by itself, the for loop itself has no allocations, whereas with LINQ, you always have allocations. All right. The next was the multiple equality comparer. Let me also flip to the code here so you can look at the code. So this was the baseline. Then multiple equality comparers, we are doing this same code here, except we are using the comparer. And the comparer is doing an ordinal ignore case rather than doing a 2-upper 3 times. We're saying, let's just compare it, that ordinal ignore case comparer. And let's look at the result of that. That is this. And it's actually slower than, and consumes more memory than the original. This to me was a bit, I didn't expect it, right? Why would it be slower? I mean, you're comparing it, ordinal ignore case, but keep in mind, even though ordinal ignore case is the sort of the more recommended version of comparison, string comparison, maybe you have a culture sensitive thing, that's a different story. Converting it 2-upper or 2-lower, and then doing a comparison is a much faster comparison by itself. It may not be the right or the correct comparison to do, but it's the faster comparison. And it's not a whole lot slower or faster. It's got more allocations. It takes a little more time. That's this one here, right? So again, I would resort to ordinal ignore case comparisons just because that's sort of more sensible to me, unless you're dealing with some culture sensitive things as well. Doing the 2-upper to do a comparison doesn't sit well. Right? Just do an ordinal ignore case. And it, as a tidbit of information, in the .NET framework, they had optimized the 2-lower implementation over the 2-upper. Okay, so the 2-lower was a bit more optimized than the 2-upper in .NET framework. And in .NET Core, they changed that to make the 2-upper more performant than the 2-lower. I'm guessing because they found that most people are using 2-upper instead of 2-lower to do comparisons like this. And so they decided to optimize that method more than this method. So anyway, just a little bit of trivia. All right. Then the merge sets was the union, if you will, where we combine. Let me show you the code. So this one set is being combined, or these 2 sets are being combined into the one set, and so then you just do a comparison. Once it's still doing a 2-upper, but of course it's happening only 1 time per iteration as compared to like over here 3 times per iteration, right? So let's compare that with that one. You can see this is actually quite a bit faster than even the baseline, right? It's got less allocation and it's faster. But remember that one of those sets got modified, permanently modified. So that may not be an alternative, right? So, but we did it anyways just to see what it looks like. And of course, we expected, since there's only one comparison, one conversion happening. So that's the difference between that and the baseline. All right. All right. Then somebody came up with this idea of just trying to do a concat. And let me show you the code here, the concat. So essentially we are taking the customers collection and we're concatenating it 3 times, like, 3 times, and then we're doing a 2 upper. So you're concatenating, so still modifying the customers, and then you're doing a first upper once. Yes, but oh my gosh, that's a lot of work. As simple as this looks in LINQ, if you were to look at the code generated for this and the allocations that occur behind the scenes, is huge amount of work, and many allocations that occur as well. And plus you modified the original list. So it's not quite working, but it was worth the shot. The idea was, when we were trying to do this, was just come up with anything wild. Let's, I've got the benchmarking stuff in place. Give me the code, and I'll just plug it into this thing. We'll see the the result of the benchmarks, comparisons, right? So no harm. If you want to just try something wild, maybe it works, maybe it doesn't. All right, so that one, as you can see, took the longest amongst all of the trials we did. All right. The next one was this, which is this one here. Now, I'll show you the code, the using query expression let. So this was the alternative, as I mentioned earlier, where you want to do this once, right? The 2 upper once per iteration. But how do you do it just once per iteration in a LINQ query? So of course, we use the query expression syntax rather than the method syntax. Then you can say let. And so it's going to do this once per iteration. And for every one of these, it's going to use this upper version to compare it with that. Right? So that's one way to do that. And sort of equivalent to that, my favorite, actually, this was my suggestion upfront, meaning while I was doing the code review itself, I said, guys, like this 2 upper thing, just do it once. And to fall in step with what the dev had already written, I said, just do it like this. So if we went from a lambda expression to a lambda statement block. What's a lambda statement block? Here it is. It's got within the where, or any lambda, is really a curly, open, close, curly. And then you have to explicitly, it's like a method body, if you will, right? It's a full out method body, unlike where you have only one line statements. We are returning the result of this bool expression. So we have to actually explicitly define or say return in the lambda statement block. Lambda expressions don't need a return statement in there, but lambda statement blocks do. All right, so what does that look like? So the query expression with the let and the lambda statement block. I don't call it lambda statement block. I call it local variable assignment for 2 upper. So we do the 2 upper once, assign it to a local variable within the lambda statement block. It's still happening just one time per iteration, even though we're comparing it 3 times. But we only do the 2 upper once. So let's compare this and this, the query expression and the statement block. All right, so that's the query expression, the blue, and then the local variable here is this one. So you can see there's a big difference. In fact, this compared to the baseline, I was very impressed, even though I was the one that came up with that immediate kind of result. Because I'm thinking just from the perspective of, I know the 2 upper is going to cost us time. So before we have that issue, let's just take it out. And this, maybe some of you don't agree with this style. I'm not saying you want to pre-optimize, but define pre-optimization, right? I'm sure a lot of people will say pre-optimize. And if you read Donald Knuth's book, or at least that one chapter, you'll realize that it doesn't just end there. But we just say pre-optimization is the root of all evil, and that we don't follow the next statement, which actually kind of explains the whole process or the whole statement much better. Nonetheless, when you know something is going to cost you, and you're not writing weird code, you're not making your code so unreadable, right? If it's just simple steps or simple things you can do to clean up your code, and if that's going to give you that little bit of performance here and there, go for it, right? I don't unnecessarily leave performance on the table. I'm talking about not kind of bending over backwards to try and get the performance. I'm talking about just simple things. For example, I've found ADO.NET to be way faster than EF. I don't use ADO.NET. Even for my little blog, I won't use it. it's just going to cost me. So my blog is running on Azure with the smallest little VM that I can buy or pay for on Azure. Why would I want to make it more expensive? It doesn't make sense. I mean, it just doesn't make sense. So that's what I'm talking about. The code looks the same. It's not any different, right? But it gives you that you're not leaving so much performance on the table. That's really what I'm getting at. So this alternative that I showed you here, this one, was basically just looking at what he had, the original baseline, if you will. This was already there in the code. I said, okay, since you have this there, I'm not happy with this part here, right? The best would be to, you know what? This is a Lambda expression, make a Lambda statement block, declare a local variable to this 2 upper once, and then use it here 3 times, right? That's it. So I would be happy with this modification. That's it. So you want to use LINQ? Great. No harm. But be sensible. Don't unnecessarily leave performance on the table. Be sensible. Use LINQ when you can, when it's simple. In my world, we use LINQ mainly for like where clauses. That's it. And even in where clauses, I can show you, even where clauses, simple, basic, simple where clauses can cost you. Okay. So, but that's okay. Right? We don't need that super duper performance every place in our system. So we don't worry about it. And it looks sort of clean. Even this may not make sense, but this compared to the for loops might actually make more sense. So we just look at the for loops now. So the first sort of comparison or implementation we had for without LINQ, right? And that was my second step was just as my own inquisitiveness. I said, okay, well, that Lambda statement block version. Okay, that's cool. But what would the for loop be? So I normally sort of baseline it at that. I say, okay, I'm using Foreach or for or enumerables, whatever the case is. Let me see what would happen with the for loop. And I shoot down to that for loop. So let me compare this with everything else. And then the difference will tell me whether I'm okay or not, right? So there's an option to use Foreach instead of for, right? And then there's the for. And then, of course, there's also the enumerable versus arrays. And there's a big difference there. One, LINQ treats the different collections, if you will, the enumerables differently. So internal to the implementation of the enumerable extension methods, like the where and the select and the count and the first and the last, all these methods, if you can imagine the implementations. Internal to the implementations, they have checks. Is this source, this collection that comes in, is this an array? Okay, if it is, then do this. If is it an I list, then do that. If it's everything else, do something else, right? So they have conditional logic where they do the implementation of the first or the select or the last or the count or whatever it is that the method is different based on the type of collection. All right. So here we're using the enumerable version of Cosmos intentionally because the Foreach will also do the same thing. This is not LINQ specific, but it's Foreach specific. The Foreach implementation also is smart. Says, okay, if I'm going to, you remember the Foreach gets lowered. Have you seen my lowering video on C#? Lowering. I'll put a link to it over here. The lowering video is the lowering step. It's a step in the compiler that happens before we compile the whole code base. Anyway, take a look at that video. I won't go into the whole. Right. So at the time of loading, the Foreach gets converted. If it's an array, it gets converted to a for loop. So the compiler, in this case, the C# compiler is smart enough to say, okay, you got your Foreach loop here. Foreach, you used Foreach. At the time of lowering, it says, well, is that an array? If it is, I'm just going to make it a for loop. Right? So to force it to use Foreach, I have to give it an enumerable so that it won't compile it down to a for loop. Right? In case you're wondering, for loops are the fastest. Foreach are second best, if you will. LINQ is the third, right? But I was trying to explain that the for loop, Foreach can also be converted to a for loop, and you might get bad or misguided readings because they're both are the same. So I'm using the enumerable here. Idea is the same. You do the for 2 upper ones, and then you compare that. Right? So per iteration, you're just doing the 2 upper ones. Then this is without LINQ, but with the for loop. So we use a for loop here. Again, same idea. The 2 upper ones, right? So we have the for version, the Foreach version, and of course there's the LINQ version. So these two, so we'll compare this one as well, the local variable. So that's the local variable one, the green. And it turns out that the for each with the enumerable actually is a bit slower now. All right. And if you look at the memory allocations, they're about sort of the same. But the LINQ for each is a bit slower with the enumerable. So the question is, how is the for each slower than the LINQ version? This is something people don't understand with LINQ. LINQ has many allocations that occur and also things that slow things down in LINQ, right? Let's take a look. Delegates. Delegates are an allocation. Delegates are slower than calling even a virtual method in C#, meaning if you call a non-static method or a static method or virtual method, they're faster than a delegate method or a delegate, right? Interface methods or classes, since you're working with an interface like enumerable and you're calling methods on it, I'm just calling them interface methods, right? Something that, of course, that it has to implement that interface. But when you call through an interface, it's slower than even calling a virtual method or a delegate. It's the slowest. So when I gave that for each and enumerable, it had no choice but to call it through the interface because it doesn't know it as some other type. It's seeing it as an enumerable. So it's calling it through the interface, and that's why it's slower. Okay, so these are subtle nuances. I'm not sure you necessarily need to worry about unless you get to that performance side, right? But it's nice to know, isn't it? It's nice to know that certain things can change slightly, but you may not need to worry about it, but at least you know why it's happening, right? So that's why it's happening. All right, then back here, done these two, the for loop. Okay, now these two other methods here, I put comments here. They basically, I'm just trying to get a difference between the two upper and not. So here, I'm not interested in getting an output. I'm going through the motions, but I'm not comparing it with the two upper. In this case, it's the for each with the enumerable, and in this case, it's the for with the array, but no two upper going on. So we're going through the motions, doing the checks, just not returning anything in the collection. All right. And that looks like that. So this is the for, and that's the for. So the difference between the two upper with the for loop and the two upper without the for loop going through the same motions is that much, right? This versus that. And allocations 280 bytes versus 32 bytes, right? Why do we worry about allocations? Exactly. Allocations may not matter. In fact, C# is super fast in allocation. It's faster than in C++, allocating. Allocations are faster. We love to create things in C#.NET. So we're super fast at allocating. We pay the price during the garbage collection. So the garbage collection is what costs us. So how do you make the garbage collection faster? Don't create so many things. The fewer things you create, the fewer things to garbage collect, the less often the garbage collection will kick in, the more performant the application becomes. Right? So that's the kind of the tension between performance and ease. So in this case, because we're creating all these strings with regards to the two upper, and just to throw them away, that's adding pressure to the garbage collection. That starts slowing things down, right? The garbage collection has to start collecting, if you will. Look at the Gen 0 collections here. Look at the difference. It's also fewer Gen 0 collections in this one compared to that one, right? That's 0.03 versus 0.003, right? So this has many more garbage collections, Gen 0 garbage collections, than that one. Only because of the two uppers, all those strings that are being allocated are being thrown away, and thus, they have to be created per iteration, and then it has to be thrown away. While here, I'm not intentionally not doing the two uppers, I'm not allocating. It's not like this is a correct code. The implementation is not correct. Those last two methods are there just to get that difference. Without the two upper, but a for loop. Without the two upper, but a for each loop. What's the difference? Right? The for each is the one, the LINQ for each. And it's got 320 bytes, and it took 430.6 nanoseconds. And the no upper equivalent is this one. So these two are LINQ for each base, basically. So again, same thing, fewer allocations between that and that. You can see fewer garbage collections and faster, almost half the time. So the 2-upper is costly. Now you may not be able to avoid it for the most part. So I'm not saying that write these two methods here, right? These are not correct. They're not giving you the right output or expected output. But then do it as infrequently as possible, which is the doing it once per iteration option, right? So again, in the actual code, because it wasn't so performance critical, that piece of code, I suggested just going with the lambda statement block with the local variable for the, the 2-upper once in the local variable, which is, I don't call it lambda statement block here, but it's this one, right? So that's this one, yep. Compared to that. And I'm good with that for like any production use where you're not trying to optimize, you're trying not to be wasteful, right? I think there's a big difference between trying to squeeze out as much performance as you can versus just, being conscious of the waste. In this case, you're creating unnecessary allocations. Why? If you can do less, why not, So just being more cognizant of the waste, if you will. So I'm good with this for production. But if you want more performance, then you might want to resort to that, which is just slightly faster. See between these two, it's 390 and 341. This is faster. And less allocations as well, right? So, but I'm good with that for production use because you're just being mindful of the waste, right? How many times do you have to do the 2-upper for the same thing? Like, can we just not clean that up a little bit? That's it. So, but I hope you found this video interesting. Some of the thought processes that went through, the different people on the team coming up with, hey, maybe if I could do a concat, or maybe I can do a merge of the sets and, and the outcome of that. And of course, eventually what was the result that we went with? As I said, this was the one with this lambda statement blocks. But I hope this was fun. I hope you learned a few things about LINQ, about C#, about the C# compiler. If you have, please give me a thumbs up. And I will see you next time.